So today we have to start the redistribution. So we'll discuss today how we can perform a redistribution from RIP to EIGRP and vice versa. EIGRP to OSPF, vice versa, and same from RIP to OSPF. Okay. So basically, we can do a redistribution, but we have to check two things. What? First of all, at what condition we can have issues?
Neeraj, we can't do redistribution in BGP?
Yes, we can do. But once we start BGP, so at that time we can do the redistribution BGP. Okay.
Okay.
Right now, what we have done only RIP, EIGRP, and OSPF, right? That's why. So if we have, but in BGP we never perform redistribution. We use a different mechanism. So we'll discuss that thing. If we have 2 points of redistribution, then we can have issues. The second point, if we are trying to redistribute routes from higher AD to lower AD. Now, okay, these 2 points are clear. If we have 2 points of redistribution and if we are trying to redistribute from higher AD to lower AD, so at that time we can have issues. What issues we can have? Routers can perform suboptimal routing. Okay, so routers can perform suboptimal routing here. Now, the question is, what is suboptimal routing? Any idea? What is this feature? Suboptimal routing.
No, fine.
Whenever a device have a best path to reach a destination but use a longer path due to AD value, that is called suboptimal routing. Clear? Let's say I'll use a diagram. So I'll use R1, I'll use R2, I'll use R3, R4, R5, R6, R7. In between 5 and 7, I will run RIP protocol. Same here, I will run a RIP protocol. EIGRP, 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 and here I will run OSPF and OSPF. Okay. So now what I will do, let's say I'm having a route here that is 7.7.7.7. So once I will send the route to R5, R5 will do a redistribution. Okay, perfect. R4 will receive the route with 8170. R4 will give the route to R2 and to R3 with 8170, right? So any doubt to this point, guys? Guys, any doubt to this point? So in this condition, R2 and R3 will receive the route with AD 170 with AD 170. Now they will try to do a redistribution. So once R2 will perform the redistribution, what will happen here? R1 will receive the route with AD 110, and same here, R1 will send the route to R3 with AD 110. Now R3 will be having two routes, one with AD 110, one with AD 170. Now R3 will choose a route with a lower AD, right? So whenever R3 want to communicate to 7.7.7.7, it will always go via R1 like this. It will never go via shortest path. Okay, and this is called your suboptimal routing. Even though R3 is having a best path to reach 7777, but due to this AD concept, R3 will go via R1, right? Guys, any doubt to this point? So this is your suboptimal routing. So once I will do redistribution, and if we have 2 points of redistribution, because right now 2 and 3 they both are working as a redistribution point. So once I will do a redistribution here in this condition, what will happen here? The routers will choose a longer path. Let's say I will do redistribution first on R3. Then in that case, R2 will choose a longer path via R1 and R3. Okay.
Okay.
Same once I will do a redistribution from EIGRP to RIP. So the route EIGRP will receive with 170 from OSPF. Okay. So once I will do a redistribution on R5, so it will send a route to R2 with AD 120. Same. Once R6 will receive the route, it will receive AD 120 and 170. Again, that will choose best path via AD 120, right? So again, the router R6 will do a suboptimal routing. So whenever router choose a longer path but has a best path, that is called suboptimal routing. Okay. So guys, tell me, like, any doubt till this point?
Could you speak again? It's too fast.
Sorry.
Could you explain again, please?
Sure. Right now, what is happening here? Let's say in between 2 and 4 we are running EIGRP. In between 4 and 5 we are running EIGRP. 3 and 4 we are running EIGRP, and same here between R4 and R6 we are running EIGRP. On R7, what we have a protocol that is RIP. Okay, and I'm having a loopback address on R7. So R7 will send a route to R5. Cool. Now R5 will do a redistribution. Okay. So once R5 will do a redistribution, this protocol, EIGRP protocol, will receive the route with AD 170 because that is external route, correct? Now R2 and R3, they both will receive the route with AD 170. Okay, perfect. Once I will perform the redistribution on R2, what will happen here? The OSPF domain will receive the route with AD 110. So once R3, because R3 is a part of OSPF and EIGRP. So R3 is getting a route from OSPF, the same route with AD 110, and the same route from EIGRP with AD 170. So which one is preferred? This one is preferred. So now R3 is having a best path, but it will go via like this, right? So R3 is choosing a longer path due to the AD concept, right? And this is called suboptimal routing. Okay.
Okay.
Okay, so this is the theory part. Now let's do the practical. Okay, we will see like what are the solutions that we can apply. The first solution, we can change AD value. I can say to this router, please use a higher AD than 170 for the EIG OSPF external route. Let's say I can say use AD 175 for the OSPF external route. Okay, so that can be a solution. The second thing, we can perform tag-based filtering. Okay, so what I will do here, once I will do a redistribution, I will use a tag value. Let's suppose I'm doing a redistribution, I'm using a tag value 111. Okay, R2 will receive the route and R3 will receive the route. So once R2 will do redistribution, R1 will receive the route with the AD 110 and with a tag value that is 111, right? I will say to R3, whenever you will receive a route from OSPF, if you receive any tag, okay, it means I will say to R3, if you receive a tag 111 from OSPF, just deny the route. If you receive a tag from EIGRP, just allow the route. Okay, so what will happen here once R3 will receive the route from R1? It means if R3 will receive an EIGRP route from other protocol, it will never accept. So these two parameters, these two solutions we can use here to achieve the same task. Okay. So any doubt in the solutions, guys?
No, for me.
Other any doubt?
No, sir, it's okay. You can continue.
No. Here I will run EIGRP. I will run here RIP protocol. So on R7 I will run RIP protocol router RIP 0000 version 2 network 670000 version 2 router summary. Okay, so the RIP protocol we have done. Okay, in between 5 and 7, in between 6 and 7, we have done RIP protocol. Now let's run the EIGRP here in these four routers. Router EIGRP 1, network 450 000, say exit, go to R6. Router EIGRP 1, network 460000. Okay, so go to R4. Let's use 0000 here. R3 34000. 34000. Okay, so in between 2, 4, 3, 5, and 6, we have done EIGRP. Now let's run OSPF here. Router OSPF1, network 0000000 area 0. Okay, go to R2. Let's run here interface based OSPF, interface F0 by 0, IP OSPF1, area 0. Go to R3, interface F1 by 0, IP OSPF1, area 0. Okay, it will take 40 seconds. Okay. The neighborship with R2 is up. Just wait for the R3 neighborship. Do show run interface F1 by 0. Do show IP OSPF interface brief. 13001 here we have. Okay, and on R3 we have 13003. Slash we have okay, cool. Do ping 13003. That is not reachable. Okay. Do show CDP neighbor. R2 is connected. Okay, do show IP interface brief. Do show IP interface F1 by 0. 13001 is on /8. Do show IP. Okay, now I think neighbor should be there. Okay, there was an issue with the interface. Do show IP OSPF neighbor and look at the neighbor should be there. Okay, so now I will start a redistribution from R7, R5 like this. Okay, I'll go to R5. I have to perform a redistribution into EIGRP. Router EIGRP. One, just do a redistribution, redistribute. What we have to redistribute? RIP. Now, whenever we do a redistribution into a distance vector protocol, so right now EIGRP and RIP protocol both are distance vector protocol. Okay, so just use a metric count here. So we have to use metric, otherwise the devices will never do any redistribution here. 1000, 1, 255, 1, 1500. Just say enter. So I'm using here bandwidth, delay, reliability, load, MTU. Okay. Just say exit. Just go to R6. Router EIGRP 1. Redistribute RIP protocol with metric count 1000, 1, 255, 1, 1500. Okay. Now go to R4 and see, do show IP route. I'm getting the route or not? Yes, I'm getting the route from both of the neighbors. Cool. Go to R3. Do show IP route. So I'm getting a route here. Go to R2. Do show IP route. I'm getting a route here also. And that is best by EIGRP. And same here, that is best by EIGRP. Right. Now let's do a redistribution into OSPF. Because look here. Right now I'm getting a route into OSPF, into EIGRP. Right. So I'm getting a route here into EIGRP, Now I will send that route into OSPF and we will check the output. Router OSPF 1, redistribute EIGRP, that process 1. Now, in the OSPF, this is link state protocol. Whenever we perform the redistribution in the link state protocol, what we do, we basically use a subnet keyword. So we have to use here subnet keyword. Without subnet, what will happen here? The device will not be able to redistribute all the routes. It means without subnet, what it will do redistribution to the only classful networks. Okay. If you want to perform a redistribution for the classless also, you have to use a subnet keyword. Okay. So using subnet, yes, the device will be able to send all the routes, classful and classless. Let me show you here the error. Look here. Without subnet keyword, what we can see, only classful networks will be redistributed. Okay. But once I'll be using subnet keyword, all the classless routes will be redistributed. Okay. Now let's go to R3 again. Now check the routing protocol and look here. Now I'm getting the route from OSPF, right? It means if this user want to do a communication, it will go via which router? R1. It will go via R1, then R2, then like this. Correct? Now, what I can do here, one more thing here, let's do a redistribution from OSPF to EIGRP. Okay, so if we are not using a good redistribution, it means we are not checking the metric values. What will happen here? We can have a loop here. Okay, so let's do a redistribution in EIGRP again. Router EIGRP 1, redistribute OSPF 1 with a metric count 10,000, 1, 255, 1, 1500. Go to R4. Look here. Now I'm getting the route from R3. Now look here. I'll show you one thing. R4 is having best path via R3. So if R4 want to communicate to R7, the best path is via R3, and R3 is choosing best path via R1. R1 is choosing best path via R2, and R2 is choosing best path via R4. Now what we have done here, while redistributing, I had used 1000 bandwidth here. While redistribution here on R3, I have used 10,000. Right, so what will happen here? R4 will choose best path via R3. So what we have here, a loop. So if we do a wrong redistribution, what will happen here? We can have a loop like this. Okay. So whenever we do a redistribution, we always check the metric value. So whenever we use a metric value, let me show you everything again. So on R4, the best path is via R3. Let's go to R3. Do show IP route, the best path is via R1. Do show IP route, the best path is via R4. Do show IP route, the best path is via R2. It means now what we have here, a loop, correct? Now let me try to check the loop. Let's do a trace and do trace 7.7.7.7 and look here. What we have here, a loop, right? The packet is going to 1, 2, 4, 3, 1, 2, 4, 3, 1, 2, 4, 3, 1, 2, 4, 3, right? So guys, any doubt to this point? So we can have suboptimal routing issues. We can have this loop also. So whenever we redistribute the information, any route into the protocol, what we check, the AD should be lower, or we can use a tag-based filtering. Okay. So right now, let me fix this issue. First of all, let me use the previous command. Let me remove this one. Redistribute with the same metric value. Do show IP route. Now it has 3 best path, but we need to just have only 2 best path. Okay, cool, no problem. We can achieve this task. So the first solution, what I can do here, I can change the AD value, right? And okay, let me do one more thing. Let me do a mutual redistribution R2 also. Route EIGRP1, redistribute OSPF1, metric value 1000, 1, 2, 5, 1, 1500. Okay. And let's do the same on R5. Router RIP, redistribute EIGRP1 with metric value 2. Go to R2. Router RIP, redistribution EIGRP1 with metric 2. So this is your hop count. At max, we can use 15. Okay, 16 will be unreachable. So the mutual redistribution we have done. Now go to R2. Or go to R3. Router OSPF1 distance OSPF. So for I have to change for external route, right? External, let me use 175. Enter. Do show IP route. Now I'm installing the route best via EIGRP directly. Okay. I'll go to R2. Do show IP route. This device is choosing best path of EIGRP pool, but yes, we have to be very careful. We have to change the AD value because maybe if R3 will advertise a route to me, I have to use the OSPF route then, correct? Router OSPF 1 distance OSPF external 175. So we have to make sure on both routers we have to increase the AD value. Do show IP route. Perfect. Okay. Now if I go to R4, now we will be having only 2 best path, and you can see what we have, only 2 best path to reach 7777. Okay. Now let's do a communication. Go to R1. Do trace 7.7.7.7 using source loopback 0. Okay. That is going to R2, then 4, then 6, and then 7. If I'll do a trace from R3, do trace 7.7.7.7. Yes, perfect. If I'll trace from R2, do trace 7.7.7.7. Perfect. Okay. So this was the first solution where what we can use, we can change the AD value to achieve the task. Okay. Now let me remove the AD concept. Now the route is best via OSPF, right? Let's do another task. I'll go to R5 and R6. So these are the redistributing routers. Okay, I will say to these routers, whenever you will perform the redistribution, just do one thing. Send all the routes with the tag value 1000, let's say 170. We can use any number. So I have to configure a route map. Tag. Set tag. Let's say 170. Enter exit. Route EIGRP 1. Redistribute RIP protocol. with metric value with the route map tag. Enter. The same commands I will configure on R6. Done. Now I'll go to R4. Do show IP EIGRP database. So this we did in the EIGRP topology table, sorry. I can see any route. I have to clear the EIGRP process to clear IP EIGRP. Neighbor. Do clear IP EIGRP neighbor. Do show run 5 section REIGRP. Let's check the configuration. We are redistributing the protocol with this metric again with the route map tag that is okay. We should see the route with the tag value. Okay, we can see here the tag value 170 and 170. You can see the tag value is 170, right? Let's run the command route tag notation. Decimal do show IP. Yeah. Okay, so right now as I can see here the route tag is 170, the route tag is 170, correct? Now let's go to R2 and R3. Just do one thing here. You have to say to OSPF. First of all, I have to create a route map tag deny match tag 170. Okay, I have to configure another route map. So whenever I will receive another routes without any tag value, that should be permit, right? So using this route map, what we are doing here, we are saying to R3, whenever you will receive a packet from OSPF with a tag value, just deny the route, and if the packet does not have a tag value, just permit the route. Okay. Router OSPF1 distribute list. I want to play with the control plane. Route map tag direction is in. Now, whenever I will receive any route in OSPF, I will check this condition. The same I will run on R2. And look here. The route is best via EIGRP again. Reason, now I'm not able to receive a tag routes from OSPF. Okay. So this is second solution where we can use a tag based filtering. In the first solution, what we can use AD concept. Okay. In the second case, what we can use a concept of tag based filtering. So this is called your tag based filtering. We are doing a filtering on R3 using a tag value. Okay. So guys, any doubt to this point?
No,
Okay, any doubt?
for me, no. For me, I need to read again a video after class.
Yeah, you have to do practice also, bro. Okay. So once you do the practice for this lab, okay, so the things will be more clear. Okay.
Okay.
Yeah, try to make the loop, try to do the suboptimal routing, and then try to prevent those things. Okay. Akram, any doubt? Hello, Akram, any doubt? Atif, any doubt?
No.
No. Okay, so the redistribution part we have done. Okay, so once we start BGP, so at that time we'll discuss how we can do a redistribution into BGP. But in BGP, we never try to do a redistribution. Okay, because always like if I do a redistribution and if we have 2 points, so at the time we have to achieve these 2 things, right? We have to use these 2 things. We can choose a AD value concept or we can choose a tag-based filtering. But in BGP, we use a different mechanism to get the routes. Okay. So using these protocols, RIP, EIGRP, OSPF, what we have a single solution using redistribution only, we can get the routes from other protocols. But in BGP, we have a different mechanism to get the routes. Okay. Using redistribution, yes, we can get the routes, but we never use this redistribution because we have some issues like this. Okay, so in BGP, we'll be using a different mechanism to get the routes. And tomorrow we'll discuss.
Neeraj, I have one question. Neeraj. Hello.
Tell me your doubt, Akram.
You can hear me?
Yes, I can hear you.
Yeah, Neeraj, do you have any workbooks for this, all this OSPF, EIGRP, RIP, and to practice?
For the workbook, what I can do, I can share the PDF file like the previous lab, the old lab. Those are obsolete. So what you can do, you can just do the practice on those labs.
Okay.
Okay. You can install those labs on your VMware and then you can do all the practice. Okay. You can use OSPF, you can use BGP, EIGRP, the switching part. You can do everything.
Okay.
I will share in the Geo drive. Okay.
Okay, sir. If you share me all the labs, old labs.
Sure. I will share. Definitely. Okay, let's do a last part here, VRF Lite with these protocols, how we can run these protocols with a VRF configuration. Okay.
VRF is used in MPLS, no?
Yes. Once we use MPLS core, then what we use with the customers, we use this VRF concept. Virtual router forwarding. So basically this concept VRF is used to create virtual routing table or we can say different routing table. Now, why we need this different routing table? Let's say I'm having R1 here. R1 is connected to R2. R2 is connected to R3. R3 is connected to R4. And all these routers are having the same route 1.1.1.1.1, 1.1.1.1.1.1, and 1.1.1.1.1. We are running here EIGRP, we are running here RIP protocol, we are running here OSPF. And then what we have another 3 customers. Now what I want, whenever R3 will send the route, only this guy should receive the route 1.1.1.1.1. Whenever R2 will send, only this guy should receive the route, and whenever R4 will send the route, only this guy should receive the route. Okay. So what I will do here, first of all, if I will not use any VRF concept here, what will happen here? R1 will receive from EIGRP with 8090, from OSPF with 8010, from RIP protocol with 8020. So what will happen here? R1 will just choose best path via EIGRP. It means R1 will send the route of EIGRP to all of the neighbors, right? But once I will use VRF, it means using VRF, what I will do, I will use a separate routing table for these 2 interfaces. I will use a separate routing table for this and this interface, and same here, I will use a separate routing table for these 2 interfaces. This is like a VLAN part. In the VLAN, what we do, we separate our broadcast domain, right? We break the broadcast domain. Same here, what we are doing here, we are breaking up the routing table, okay? So let's say here we have 6 interfaces, F0 by 0, F0 by 1, F1 by 0, F1 by 1, F2 by 0, F2 by 1. So what I will do, I will configure these 2 interfaces into a single VRF table. Same here, I will configure these 2 interfaces into a VRF table. Same here, I will configure these 2 interfaces into another VRF table. So what will happen here, whenever I will receive a route here, it will just go to this interface. Whenever I will receive a route here, it will just go to this interface. And whenever I will receive a route here, it will just go to this interface, okay? Now, let's do the practical on this diagram. So I'll be just using R2, R3 and R4 and R5, only these three routers. Okay. Let me remove. So in between 2 and 4, I will use EIGRP. Okay. In between 3 and here, I will use the RIP OSPF, and here I will use RIP protocol. Okay. IPVRF, let's say, I can use any name, no problem. Okay. EIGRP. Okay, so once we configure these things, we have to define RD value also. Okay, but right now about the RD value, we'll discuss in the case of MPLS. Right now we'll just do a configuration of VRF. That's it. IPVRF OSPF, IPVRF-RIP. Okay, so we have these three tables. Okay, so before assigning the VRF to the interface, what we do, we check the running configuration. The reason, once I will use a feature VRF on the interface, the device will just flush all the IPv4 routes. F2 by 0. IP VRF forwarding EIGRP. Okay, so this is the command to enable a VRF on the interface. Enter, and look here. Interface 2 by 0 IPv4 disabled and address is removed due to enabling VRF EIGRP. Okay, so now let's do copy and paste from F2 by 0. Interface F2 by 1 IP VRF forwarding OSPF. Just run this command again. So using these commands, what we are doing here, we are just trying to use this interface into a different routing table. Interface F0 by 0 IP VRF forwarding RIP. IP address 45004 to 45000. And then doesn't matter the neighbor is using the same thing or not, okay, because the VRF is a concept of local to the router always. Okay, exit. Do show IP VRF. So I can see the interface F2 by 0 is a part of EIGRP, the interface F2 by 1 is a part of OSPF, the interface F0 by 0 is a part of RIP, and the interface that is remaining interface F1 by 0 is a part of global table. So once I will run the command do show IP route, I can just see only 46, that is a part of global. Do show IP route VRF EIGRP, I can see 24. In OSPF I can see 34. In the RIP protocol I can see 45. Cool. Now let's run the protocol. Router EIGRP1. Now we have to run EIGRP for which protocol, for which feature, VRF feature. Address family IPv4 VRF. So like this we enable EIGRP for a VRF. VRF name is EIGRP. And then again I have to say autonomous number, that is 1. Okay, that is mandate again. Here we are defining the autonomous number. But again once we configure the VRF, we have to define the OS number again. Just say the network 24000. Go back. Router EIGRP. Sorry, let's run OSPF now.
They have to be on the same network.
Yes, basically it will use here network 000 also. What it will do, it will try to check this VRF table only. And in this VRF table, how many routes we have? Only the single interface. So we can also use here 000. That doesn't matter. Okay.
Okay, but as long as that then
yeah, it will always take the same table to inject the routes.
Okay. It will just match the table.
Yes, right. Like if I talk about once our switch will receive a packet into VLAN 1, it will just check the members of VLAN 1, right? Not a VLAN 2, correct? Same here, once it will receive, it will check the network command in the VRF. So it will just check the VRF, the routing table to inject the routes. Okay.
So in the enterprise, I think in the enterprise connectivity on the internet router, only I think the VRF is created so that it can pair with the ISP's router, right?
Basically, the ISP router use the VRF concept because the ISP can have multiple neighbors, right? And those multiple neighbors can use the same subnet. If they are using same subnet and they are not using VRF, so the route will get mixed, right? So they have to use VRF concept on the provider edge router. Okay. Once we start MPLS, we'll discuss how the provider edge routers use a concept of VRF. Okay. We'll discuss. Router OSPF1, how we run OSPF? Just say here VRF. OSPF, use a network command. I can use 0000, no problem, because right now we have only one single interface into OSPF, so that doesn't matter. Router RIP, address family IPv4, VRF name is RIP. Again, you can use network 000 because it will just check the table of RIP, exit. Now let's use the same interface loopback 0, IP address 1.1.1.1, 255.255.255.255, loopback 0, IP address 1.1.1.1. I'm using the same loopback address and I can see that loopback address individually in the each routing table. I'll go to R4 now. Do show IP route. So this is a global table. I'm not getting any route. Do show IP route VRF EIGRP. I can see that route 12. Okay, I will receive 1.1.1 also. Just wait. I'm getting 1.1.1.1.1. Do show IP route VRF OSPF. I'm also getting here 1.1. Look here. I'm getting this one into EIGRP. I'm getting this one into OSPF. Do show IP route VRF RIP protocol. And I can see here I'm getting the route from RIP protocol. So once now in future, what we have here, 3 different VRF, correct? So one VRF name is RIP, one VRF name is EIGRP, one VRF name is OSPF. So once I will inject this interface, let's say into this protocol. So I will just get the route of this router. Or let's suppose I will put this interface into this VRF. What will happen here? I will get the route of this interface of this VRF. If I put this interface into the VRF RIP, so I will get the route of R5. Okay. So this is the concept of VRF. I think this concept is clear, right? Guys, any doubt till this point?
Yes, no doubt.
Akram, any doubt? Always any doubt?
No.
Okay.